The United Arab Emirates is running a colossal, multi-hundred-billion-dollar experiment against reality. If it fails, the modern world's most ambitious cities turn back to sand. Right now, nearly 10 million people live in a nation carved from the Arabian desert, a landscape that receives less than 100 millimeters of rain a year. They survive, thrive, and build monuments to the future on a water supply that is almost entirely manufactured. One single source provides over 99% of their drinking water: the sea. And that sea is getting hotter, saltier, more hostile. For 50 years, the UAE has perfected the art of making the ocean drinkable, but the technology is reaching a physical limit. And climate projections warn that the Arabian Gulf itself could become too saline for even the most advanced systems to manage effectively. Do you think a city can truly engineer its way out of any climate problem? Let us know your immediate thoughts in the comments below. This is not a story about conservation. This is a story about creation, about a nation forced to produce its most vital resource from thin air and the unimaginable cost of that dependency. We put months of research into documentaries like this, and a huge number of our viewers watch every single second but forget to subscribe. If this is the kind of deep analysis you value, please take 1 second to hit the subscribe button. It is a simple click that tells YouTube you want to see more, and it is the single most important factor that allows us to continue making these investigations. It's an emergency for us, and it's important. Don't miss what's coming next. Subscribe now. Let's begin. The plan was never to just survive, it was to conquer. The UAE's core challenge was not a lack of money or ambition or political will. It was a fundamental deficit in the laws of nature, and their response was to build one of the most energy-intensive, technologically complex life support systems ever conceived. They called it desalination. It was supposed to be the final answer. But here's what they didn't tell you. The process that gives life is slowly killing its source. The waste product of creating fresh water is making the sea itself undrinkable, and the entire system is caught in a feedback loop that has no clear exit. So the question is not whether the UAE can afford to keep the water flowing. The real question is, has this desert nation built a miracle of modern engineering, or has it just constructed the world's most expensive machine for its own destruction? Dubai, Abu Dhabi, these were never inevitable cities. Before the discovery of oil in the 1950s, the land was home to a sparse population of Bedouin tribes and coastal communities. Life was governed by a brutal calculus of water. Survival depended on a handful of small, brackish wells and the ancient system of afflage, ingenious man-made channels that tapped into scarce groundwater tables and guided the flow for kilometers to sustain small date palm oases. These were not rivers. They were threads of moisture, meticulously managed, defended, and revered. The entire economy, based on pearl diving and fishing, was dictated by the seasons and the unforgiving heat. The idea of a city of millions, of lush green parks and towering skyscrapers, wasn't just fanciful. It was a physical impossibility. This was a place where nature had drawn a hard line, a place where human settlement existed only at the margins, by the grace of a few hidden drops of water. Then came the oil. The discovery transformed everything. It wasn't just wealth that flowed from the ground. It was power, the power to override the environment. The founding father of the UAE, Sheikh Zayed bin Sultan Al Nahyan, held a vision that seemed utterly disconnected from the landscape around him. He envisioned a green, modern, and prosperous nation, a hub for global commerce and culture. He famously said, "Give me agriculture and I will give you civilization. But to have agriculture in a desert, to build a civilization on sand, you need water. Not in drops, but in torrents." The groundwater that sustained the old world was quickly depleted. It was a finite resource, a fossil relic of a wetter climate thousands of years ago. Using it to build the future was like trying to fill an ocean with a thimble. It was a losing battle from day one. The solution came from the coast, the vast, hyper-saline waters of the Arabian Gulf. In the 1970s, the UAE, alongside its wealthy Gulf neighbors, began investing in a technology that was, at the time, revolutionary: desalination. The process of removing salt from seawater to produce fresh, drinkable water. The first plants were monuments of brute force, gargantuan facilities like the Jebel Ali Power and Desalination Complex in Dubai. It started small, but its purpose was monumental: to decouple the nation's destiny from its geography. The early technology was multi-stage flash distillation, or MSF, an industrial titan of a process. It is, in essence, a profoundly simple idea executed on a colossal scale. The system takes in massive volumes of seawater, heats it under pressure, and then passes it through a series of chambers, each at a progressively lower pressure. In each chamber, a portion of the water instantly flashes into steam, leaving the heavy salt and brine behind. That pure steam is then collected and condensed back into ultra-pure distilled water. It is reliable, it is powerful, it is also breathtakingly inefficient. What do you think is the single biggest unseen cost of living in a hyper-modern city like Dubai? The energy, the environmental impact, the social cost? Share your perspective in the comments. MSF plants are effectively giant industrial kettles. They consume astronomical amounts of energy, burning natural gas to generate the intense heat required to boil the sea. For decades, this was a trade-off the UAE was happy to make. Plentiful, cheap fossil fuels were transmuted into plentiful, life-giving water. The equation worked. Population boomed. Dubai's skyline erupted from the desert floor. Abu Dhabi became a global center for finance and culture. The country built championship golf courses, sprawling residential communities with lush gardens, and even an indoor ski slope, all serviced by water that was, just weeks before, part of the Arabian Gulf. It was the ultimate demonstration of wealth and will, a complete defiance of environmental limits. An entire country built on a manufactured resource. The engineering was a triumph. The cost was an afterthought, the consequences were a problem for another generation. But the demand never stopped growing. Every new skyscraper, every new tourist, every new palm tree planted along a boulevard needed water. The MSF plants, for all their power, were relics of a less efficient era. A newer, more sophisticated technology began to take over. Reverse osmosis, or RO. This was not a process of brute force heat, it was a process of immense pressure and delicate filtration. RO works by forcing seawater at incredibly high pressures against a series of semi-permeable membranes. These are sheets of polymer material engineered with pores so microscopic that they allow water molecules to pass through but block the larger salt ions, along with other minerals and impurities. It is technological finesse, where MSF was industrial might. The energy required is not for heat, but for pressure. Giant pumps, humming with power, create the forces needed to overcome the natural osmotic pressure that would otherwise keep the water and salt mixed. The advantage was immediate. RO plants used significantly less energy than their MSF predecessors. They could be built in more modular, scalable forms. They represented a smarter, more sustainable path forward, or so it seemed. Today, a plant like the Tawila reverse osmosis facility in Abu Dhabi is a marvel of the modern world. When fully operational, it is one of the largest on Earth, capable of producing over 900 million liters of fresh water every single day. A river of life, created from the sea through the power of engineering. And it's here in the cold, hard efficiency of the RO process that the true crisis begins to reveal itself. The membranes are not magic. For every liter of fresh water they produce, they leave something behind. A highly concentrated, super salty slurry known as brine. This is the accumulated waste of the desalination process, a toxic cocktail of double-strength salt water mixed with anti-fouling chemicals and cleaning agents used to keep the delicate membranes from clogging. And for 50 years, the solution for what to do with this brine has been brutally simple. Pump it back into the sea. Day after day, year after year, billions of liters of this hot, dense, chemical-laden brine are discharged back into the Arabian Gulf. It's a solution born of convenience, an out-of-sight, out-of-mind approach to industrial waste. But the Arabian Gulf is not the Pacific Ocean. If you know someone who is fascinated by massive engineering projects or the challenges of climate change, share this video with them. Liking the video also helps us reach more people who need to see this story. It's a huge help. The Gulf is a unique and dangerously vulnerable body of water. It is relatively shallow with an average depth of only 50 meters. It is semi-enclosed, connected to the wider Indian Ocean only by the narrow constricted Strait of Hormuz. The water that enters the Gulf can take years. Some studies suggest 3 to 5 years to fully circulate and exit again. This makes it a natural evaporation basin. It is already one of the warmest and most saline seas on the planet. And dozens of the world's largest desalination plants, not just in the UAE but in Saudi Arabia, Qatar, Kuwait, and Bahrain, are all clustered along its shores. All of them are dumping their brine into the same slow-moving bowl of water. The consequences were predictable. They were modeled by scientists decades ago. Now they are being measured. The solution is poisoning the source. Studies conducted by marine scientists and oceanographers have confirmed a measurable increase in the salinity of the Arabian Gulf, particularly in the coastal areas where the desalination plants operate. The effect is no longer theoretical. It is a documented reality. The brine, being denser than normal seawater, sinks to the seafloor, creating dead zones where the extreme salinity and lack of oxygen make it impossible for most marine life to survive. The elevated temperatures from the discharged water exacerbate the problem, bleaching coral reefs and putting the entire marine food web under intolerable stress. A system designed to sustain human life on the coast is systematically destroying the oceanic life just offshore. But the ecological catastrophe is only the beginning of the problem. The real threat is the feedback loop it creates. As the baseline salinity of the Gulf water increases, the desalination plants have to work harder. The RO membranes must contend with a higher concentration of salt in their source water. This requires more pressure. More pressure requires more energy. More energy means a higher cost and a greater carbon footprint. And a higher initial salt concentration means the resulting brine is even more concentrated, even more toxic. When that is discharged, it pushes the Gulf's salinity up another notch. The cycle repeats. Harder work, more energy, saltier brine, a saltier sea. It is a spiral of diminishing returns. The engineering solution is actively and measurably making its own core problem worse with every liter it produces. I know this is the second time I'm bringing this up, but our analytics show a shocking number of you who love these deep dives are watching right to the end without being subscribed. It's like watching your favorite team every week from outside the stadium. Come on in. The ticket is free. Hit that subscribe button. It takes 1 second and it ensures you never miss these investigations. Let's fix that statistic together. The ultimate, unspoken fear among water resource planners in the region is the concept of terminal salinity, a point at which the salt concentration of the Gulf becomes so high that conventional reverse osmosis is no longer economically viable, or perhaps even technically possible on a mass scale. The energy required to push water through the membranes would become astronomical. The rate of membrane fouling and decay would accelerate. The system would, in effect, break. It would be choked by the very hyper-salinity it helped to create. This isn't a distant, abstract threat. Climate change is acting as a ruthless accelerator. Higher global temperatures mean a hotter Gulf. Hotter water holds less dissolved oxygen and promotes the growth of algae blooms that can clog desalination intakes, a phenomenon known as red tide. More severe heat waves on land mean less rainfall, higher evaporation rates, and an ever-increasing demand for desalinated water. Every single effect of a warming planet tightens the screws on this already strained system. The UAE finds itself in an impossible position. To survive the heat, it must make more water. To make more water, it must burn more energy and dump more brine. This, in turn, damages the Gulf and accelerates the very climate change that is driving the crisis. It is the perfect, terrifying loop, a nation running as fast as it can with the most advanced technology money can buy, just to stay in the same place. The leadership of the UAE understands this. They are not blind to the physics of their situation. Their response has been a new wave of audacious engineering, moving beyond the coast and into the sky itself. The UAE National Center of Meteorology operates one of the world's most active and well-funded cloud seeding programs. This is not science fiction, it is operational atmospheric science. Fleets of specially equipped aircraft fly into promising convective cloud formations. They fire hygroscopic salt flares into the updrafts of the clouds. These salt particles act as giant cloud condensation nuclei, attracting tiny water droplets and encouraging them to merge and grow until they become heavy enough to fall as rain. It is a high-tech rain dance, an attempt to wring a little extra moisture from a sky that is determined to give none. The program has claimed successes, with data showing enhanced rainfall in seeded clouds compared to unseeded ones. Videos of sudden downpours in the desert are hailed as victories, but the engineers are candid about its limitations. You cannot seed a clear sky. The program is entirely dependent on the presence of the right kind of clouds, a meteorological condition that remains infrequent in the arid climate. Cloud seeding is a supplement. It is a marginal gain. It is not a replacement for desalination. It is a sign of desperation as much as it is a sign of innovation, a recognition that the coastal solution is not enough. Something else is needed. Deeper in the desert, another, even grander project is underway, a project that speaks directly to the fear of total system failure. In the Liwa Desert, not far from the Saudi border, the Abu Dhabi Water Authority has constructed one of the largest artificial water reservoirs on Earth, not a surface lake, but a vast, strategic reserve hidden beneath the sand. For years, they have been pumping billions of liters of high-quality desalinated water from the coast, through hundreds of kilometers of pipelines, and injecting it deep into a natural underground aquifer. The goal is to build a massive emergency reserve, a savings account of fresh water that can supply the country for up to 90 days in the event of a catastrophic failure of the desalination plants. A red tide event that shuts down intakes, a geopolitical crisis in the Strait of Hormuz, or the slow creeping crisis of terminal salinity. The Liwa Strategic Water Reserve is an engineering masterpiece. It is also a profound admission of vulnerability. It is insurance purchased at a cost of billions of dollars. Not a solution to the water crisis, but a buffer against its ultimate conclusion. It is a plan for what to do when the machines on the coast finally stop. The final frontier of innovation lies in the waste itself. The dream is a concept called zero liquid discharge, or ZLD. The idea is to treat the desalination brine not as waste to be discarded, but as a resource to be mined. Advanced ZLD systems use further stages of evaporation and filtration to extract every last drop of fresh water from the brine, leaving behind only solid crystallized salts and valuable minerals like magnesium, calcium. In theory, this closes the loop. It eliminates the discharge of toxic brine into the Gulf and creates a new revenue stream from the harvested minerals. The reality is, once again, the brutal laws of thermodynamics. ZLD technologies are punishingly expensive and consume even more energy than desalination itself. While they are being piloted in smaller, specialized industrial applications, scaling them up to handle the biblical volumes of brine produced by a nation like the UAE is, for now, economically unfathomable. It remains a distant ambition, a technocratic hope that another engineering leap can solve the problems created by the last one. But that leap has not yet arrived, and the Gulf continues to grow saltier. So the UAE is trapped. It has built a glittering, hyper-modern society that stands as a testament to human ingenuity. It has defied its own environment, funded by a fossil fuel boom that, in a dark irony, is now driving the climate change that threatens its very existence. The nation has done everything right, according to the playbook of 20th century progress. It invested in the best technology. It planned for growth. It built redundancy into the system. It is now pushing the boundaries of atmospheric and geological science to secure its future. But the problem may not be one that engineering, no matter how audacious, can solve. The numbers are relentless. Population growth, rising temperatures, increasing salinity, dwindling options. The UAE is a showcase for the world. A vision of the future, but it may also be a warning, a glimpse of a coming era where our most advanced technology is not enough to outrun the consequences of our own consumption, where the staggering cost of survival becomes a crisis in itself. Phoenix, Los Angeles, cities across the world's arid regions are watching. They are all dependent on their own complex systems of water delivery, from distant rivers and depleting aquifers. They are all facing their own version of the UAE's dilemma. Okay, I know, I'm back. I promise this is the last time, but it's crucial. If you've made it this far, the algorithm already knows you like this content, but it doesn't know how much unless you're subscribed. By subscribing, you're not just getting our future videos, you're joining a community dedicated to understanding these complex global challenges. So consider this your official, final, humorous, but deadly serious invitation. Hit the button. It matters more than you know. Las Vegas drilled a hole to the bottom of its lake. The UAE built a machine to boil the sea. Both are acts of incredible determination. Both are attempts to hold back a changing planet with concrete and steel. But the water in the Arabian Gulf is not just a resource. It is part of a complex living system, and that system is beginning to fail. The skyscrapers of Dubai may be the tallest in the world, but they are built on a foundation of manufactured water, a foundation that is slowly, perceptibly dissolving back into the sea. The third straw in Lake Mead bought Las Vegas time. The desalination plants of the UAE bought an entire nation a future. The question that remains, hanging in the hot desert air, is how much time is left on the clock. The engineering solved one problem, but it created a new one. A problem that is quieter, slower, and far more fundamental. A problem that may not have an engineering solution at all. The water still flows, the cities still glitter, but the sea is keeping score, and its patience is not infinite.